Allow me to walk through this topic: mean or expected value and standard deviation. We will go through this first: mean or expected value. What is an expected value? Let me find. Well, I had a coin with me. Yeah, I have a coin, and in statistics, when we have a probability, it means that, well, let's imagine that we chose this coin a few times, and what would you think the result would be? Let's say 4 times it is flipped, and, well, let's say that we got all heads or all tails, but that's not what we may expect. We expect that 2 times we get heads and 2 times we get tails, and that is expected value. An expected value is when you expect something to happen in the long run, not in the short run. Because if you may get with this coin, you may get all heads or all tails, or 3 heads and 1 tail. And that's not what you expect. You expect 50-50. Let's imagine that for the heads equals to 1, and for the tails equals to 0. And we can work with these numbers. Let's say we put 0 here and 1 here. So the probability of x is 1 over 2, because to have 2 options, and one of them is head and one of them is tails. So it is the same for the tails, and p times x, the value times the probability of x. So 0 times 0, 1.5 equals 0.5. 0.5, sorry, that is equal to 0. Just 0. Because every number multiplied by 0 is 0. And now 1 multiplied by 1/2 equals 0.5. 0.5. The next thing we do is a summatory, or a sum of all these numbers. If you know how to call this signal, say that this sign, please tell me. I would like to know how you call this sign, and that's the sum of 0.5 plus 0, 0.5. Now we have found the mean or expected value, which is 0.5, and as I mentioned, in the long run, not in the short run. So let's put it here. Let's put here mean equals to 0.5. We already knew this value. The second topic we have is standard deviation. The standard deviation is the square root of the sum of x times the mean, and this value we square it to the power of 2 times p of x. Let's write it. This signal is called sigma, and we use it to represent a standard deviation. It will be the square root of the sum of x minus 4. Sorry, it's not 4. It's another signal. It's like the p. Something like it. And it is equals to the mean. Now this we raise it to the power of 2 times p of x, its probability. With this formula, we get the standard deviation. Now let's do it. We have a we have x, which is 0 and 1, and let's erase this and let's put it in another place. Let's put it in another place. So it will be, let's put it here. I don't have any space. It will be the square root of the sum of x minus the standard, the expected value to the power of 2 times p of x, p of x times p of x. Now, we start with the 1 or 0 that we have in the values of x. Let's draw a line here and let's put it for this value multiplied by 0.5, that is the mean. 0 times 0.5, 0 times 0.5 equals to 0. Now, no, 0, no, sorry. We have, let's, at the end we're going to get the square root. Let's deal with that at the end. Let's focus on these two parts. So the first would be 0 minus the average, the mean, which is minus 0.5, is to the square to the power of 2 times p of x. What is p of x? P of x is equals to 1 1/2. Now the second one, we get 1 minus 0.5 to the power of 2 times the probability is the same, 1/2. So we get this equals to 0 minus 0.5 minus 0.5 times the square to the square. We get, I have it here in my notes. We have it minus 0.5 times equals 0.25, because, well, if we get here 0 minus 0.5 equals minus 0.5 to the square root, we get a 0.25 positive, since we get minus, this is equal to minus 0.5, and when we square it, we get 0.25 positive. That was why I was surprised. Now, this value will multiply it by 1/2, and 1 times 1 minus 0.5, we get 0.5 squared. We get the same result, 0.25 times 1/2. So when we get this to multiply 25 times 0.5, that would be 1/2, we get 0.125. Let's put it here. These two are equals to 0.5. And this 0.5 times 25, 125. 0.125, 0.125. Now we get the sum of this 0.125 plus 125, 0.125, to get 250, 0.250, 0.25. we get 0.25. So 0, the square root of 0.25. And I'm not sure about 0.25 because 0.125 that will be 1, but the other concerning 0.5, well, and if you calculate that in your computer, it will be the same. But I guess it is 0.01. But it actually makes sense. It makes sense. So the square root of 125 will be equals to 0.5. 0.5. Yeah, 0.5. So that will be the, well, where is the signal? Where is the signal? Let's have it here. Sigma. And sigma is the representation for standard deviation. And what is this useful for? This is useful for when we want to calculate so the average result. No, the interpretation is the standard deviation 0.5, which means the result 0.1 always from, well, at this point, since this is a very simple example, you get that the two results, the mean and the standard deviation, are the same. But this is the principle. You have to use this rule and this other, multiply the initial value times its probability, and you get the sum of that to get the probability, the mean. That's all it takes. And if you have something to, you have a comment, or you want me to improve in your area, or you don't want me to start looking at my screen, my computer is at this side, please comment on the description box below, and I will try to improve for next time, being more prepared. I'm not doing this because, well, I want to show how much knowledge I have or how professional I am. It's only because I learned something. If you learn one thing with your head and you don't use your mouth to explain it, you are not memorizing it at all. And that's why I'm doing these videos. So if you find this video helpful and you are blessed with this material, uh, give thanks and write me in the comments. That will be all for today. Thanks for watching.